Hi everybody. I was waiting for somebody to post a problem that I could actually do. Um, I cannot emphasize this enough. You have to give me specific problems to work, or else I can't do anything for you. If I were to make up a problem for average atomic mass, I would pause the stream and I would come back in an hour. That's how long it takes to write these problems, because I have to pick numbers that work. I have to do the calculation forwards, then I do it backwards to make sure that it works. Um, and that takes time. So please find specific problems that resemble what it is that you would like me to go over. I don't know why I'm looking in the workbook. I have the workbook in front of me. I have the PDF of it right here. I could just open that up, and then you could see it too. So let's do that. Workbook. So number 7, or unit 7. And then which one did we want? We wanted number 6. So let's see here. 2, 4, 5, 6. Where's the part where she has just the printed answer? There we go. I can get all of that on the screen. Look at that. Okay. Sorry, I had to move the mouse over here. It's not very sensitive. There we go. I got it on the screen. Okay. The average atomic mass of carbon is 12.011 AMU. We're only going to look at its 2 most abundant isotopes, carbon 12 and carbon 13. What are their natural abundances if their atomic masses are 12.000 and 13.0033? Okay. So let's put all that in a table here. So we've got carbon 12. We got carbon 13. So we have the mass of that, which is... I haven't rebooted Photoshop. I really should have, but I immediately got into a conversation with somebody that was rather serious, and they needed me to talk to them. I don't know if you have dealt with a family member that has had, like, dementia. Well, this is happening to a friend, and he needed support. So I was talking to him for an hour, and then forgot to reboot the computer. So now my Photoshop is complete garbo. So if I draw something like this and it starts overwriting like that, I apologize. I'm aware that it is an issue with my computer, and I need to reboot. So, but if you can't read something on the screen, let me know. 0033. Oops, I forgot my AMU here. We do want units. There we go. So there's our mass, and then our percentages we don't actually know. So I'm just going to put question marks here. Actually, no, I'm not going to put question marks. Because we're going to immediately replace them with that, right? So here's our information. And what we want out of this is that when we have a... We want to figure out the number at the bottom of the box for carbon here. So how exactly do we go about doing that? Remember that the formula for average mass... Wait, no we don't. This is not at all what we want to do. Hold on. We actually know this number because it says that in the problem. There you go. So that information is provided. So what we want to find out are X and Y here. So the formula for the average mass is equal to the mass of our first isotope times its percent plus the mass of our other isotope times its percent. And we would keep doing that for every isotope that we have, but we only have 2. So what numbers are known? I know the average mass, that's this right here. I know the mass of carbon-12, that's this right here. And I know the mass of carbon-13, that's right there. What I don't know are these percentages, which I'm going to replace with the variables that we've elected to give them. So we've got X for the percentage of carbon-12, and then we've got Y for the percentage of carbon-13. In order to complete this, we need another equation, but we do know that if I add the percentages together, I get exactly 100%. So using these 2 equations that I have right here, I can then solve for my 2 variables. Now, just like I did it when I gave the lecture on this, I don't know how long ago Unit 7 was. It sure feels like a long time ago. I'm going to show you the algebra, but then we're going to go to Wolfram Alpha and just solve it. Because I think it's important for you to be able to do the algebra in case you're on campus next quarter. If you're taking my 161, you're going to be doing this online, so it's all the same. But if you're taking 161 with somebody else and it's like in person or whatever, maybe not even at Everett, maybe at a different college or at UW or something, like whatever you're doing. This is how you would be expected to solve it if you didn't have a solver available. So the first thing that we're going to do is we're going to solve this equation for one of the variables. I'm going to just pick X. So that means that X will be 1 minus Y. And I'm going to substitute that into the expression for X. I realized I pointed at the wrong thing there. And so that's going to look like this. So M average is going to be the mass of carbon-12 times X, which we've substituted, plus the mass of carbon-13 times Y. And we're going to factor this in, kind of like FOIL, but we only have one thing to FOIL, so. That's supposed to be a 12, but for some reason my pen is connecting all the dots. So mass of carbon-12 times 1 is just the mass of carbon-12, minus Y times the mass of carbon-12, plus Y times the mass of carbon-13. Now, the next thing I'm going to do is I'm going to move all the Y's to one side. I've already got them all on the right, so I'm going to move this over here to get rid of it. And then I'm going to swap these two so that I have something minus something else. So that's going to make this look like this. And then I'm going to factor out Y. So I'm going to do parentheses, and I'm going to pull Y out of there. So just like we did before where we multiplied in the mass of carbon-12, I'm going to unmultiply by Y and put it out in front. So this stays the same. And then the Y comes out front. So I have 13 minus M12. And then the last step is just to divide both sides by this thing. And so if we do that, I swear, Photoshop. It's because I need to reboot the computer. Windows 10 is not likely to have my computer up for a whole week. I have to reboot it, I guess. When I was using Windows 7, I could leave my computer running for like 4 months at a time and it'd be fine. All right, so there's Y. Y is just all those numbers, and we have all those numbers. They're up above, and we'll just fill them in. So the average mass was this, 12.011 AMU. The mass of carbon-12 was exactly 12. I'm going to underline it just to indicate that. And then we have mass of carbon-13, which was 13.0033 AMU, minus the mass of carbon-12, which was exactly 12 AMU. All right, since these are exact numbers, that means that I'm going to be able to keep to whatever decimal place that I had here. So that would be the thousands place and the 10,000s place. So when I go to this here, 12.011 minus exactly 12. Oops, I have this crazy ass number in here because I was just hitting buttons. I'm going to get this, just this for my answer. For the top number. And then when I do the bottom, oops, I gotta actually be on the calculator. I have to keep all those digits. But I'm gonna kind of lose that precision anyway. Why is this not working? That's weird. Oh, I see what happened. Okay, hold on. Yeah, you can actually kind of see what I was trying to write there. Because if I type in the number pad on accident, it changes the opacity. 1.00. So those cancel out. And then now I can just do this. 0.00. Oh, I did it again. Hold on. 0.00, or sorry, 0.011. 1.0033. And so I get 2 sig figs here, so 0.011. And for some reason the pen is now thicker. Because reasons, I don't know. Okay. So remember that this was Y, so we'll go up here and fill that in. So Y was 1.1%. And so X must be 100 minus that, or 98.9. All right. Oops, I scrolled right past it. So there's the answers that Samita got. Now, you can get different numbers of sig figs depending on which direction you do the problem. And that's kind of obnoxious. Because if I had substituted below and solved for x instead, or I'm sorry, solved for y as 1 minus x, then I'd be just subtracting different numbers when I got down here. In fact, the whole expression would change. And so I'd have different numbers in the subtraction, and so I might have a different number of sig figs as a result. So doing it this way, our answer should have 2 sig figs. If we did it a different way, we would have a different number of sig figs. And it's, again, going to depend on how your expression turns out when you solve for your variable. All right, there was that problem. Is there another one hiding back here? I have the calculator in the way. Okay, there is not. Can I make this smaller? Not really, unfortunately. Does this actually change what's on screen? Oh, yeah, it does. Okay, I see what's going on there. That's weird. It just makes it longer. I'm just stretching out the calculator here. It just looks really stupid. Okay. Other questions. If you have anything specific, let me know. I do need specific questions. In this morning's class, they asked me kind of a vague question, so I tried to make up something, and I made a question that if you Google it, you get the wrong answer. So that was good. When I don't have time to do my research, you get garbage results because intuitively I can make problems for you, but they may not match up with reality. So, Unit 16, number 5. That's number 6. Hold on. All right. 3/4 of a gallon of 1.50 molar sodium bicarbonate was evaporated. Calculate the weight of the solute in pounds that will remain. And there's the molar mass on the board, so we don't have to actually go to Lentech for that. Okay. I call this a Samhita problem because the units are Garbo. Samhita loves to throw US units and like imperial units at you. Because I guess she hates fun. No, I'm just being silly. So, really, it's for practice, and I think it's good to do these types of problems on occasion. I'm not going to put them on the exam where you have to convert 74 billion units to get from like cubic yards down to milliliters, because I just can't be bothered. that's too much work. But we can do that here. I mean, I could do it if I can get to my screen here. So we're going to get rid of this. If Samina is watching, I don't apologize. I hate all of your problems. There are too many stupid units. Alright, so we got this many gallons. We know that the concentration of the solution is this many moles of sodium bicarbonate per liter of solution. So I have a molarity and I have a volume. Remember what you can do with molarity times volume. It's just that the units on these things don't match, right? So I would need to make them match. So let's start with the volume. Let's get that to liters. And I don't know the conversion from gallons to liters off the top of my head. 3.7854. That's good enough. Liters per gallon. So we'd all agree that what is in this parentheses, that's the amount of gallons. So I don't have to actually hit enter on that calculation. So then what I'm going to do is I'm going to go like this. I'm going to then multiply by the molarity. And then I can just do that, right? Just because it's in the parentheses doesn't mean I can't cancel it. And so this would be the number of moles in the sample. I don't know why I'm starting with 1.50, but that's okay. Times 0.750 times 3.785. So there were that many moles in the sample, and I get 3 sig figs, so it's 4.26. Now I have moles, but what is the problem specifically asking for? I have to look that up. Can I get the weight of the solute in pounds? Okay. So we'll take that number, and you could do all this in one giant calculation if you wanted to. It's just that I don't have enough space on this to do that and to fit it all in one screen. So we'll do it this way. So I'm going to turn moles. Oh, for fuck's sake. Into grams. And in 1 mole, according to there right at the top, the molar mass is 84.01 grams per mole. And then I can turn... Oops, what am I doing? Not grams to moles. Sorry. I'm on autopilot here. We'll turn grams into pounds. And 1 pound is 453.6 grams. That one I do have memorized. And so this would give us the mass of sodium bicarbonate in pounds. And so we'll do that. 4.26, 84.01 over 453.6. And we get, for 3 sig figs, 0.789. And that should be what the solutions key says. And it totally does. Oops, it's not scrolling because... There we go. That's the answer that Samita got. Alright, Unit 13. Let me find Unit 13 here. This is good. Yeah, just keep posting them in the chat and I'll just do them one at a time. Question 2. For question 2, these are all the same type of problem. Do you have one that you would prefer that I do? Just because... Pick one. You know what? I will defer to the D4. So let's see here. We'll just say 1, 2, 3, 4, A, B, C, D. I don't know if this will pick up. There we go. I got 1. Because when I play the sorcerer and a D4 was my hit die, of course I'm going to roll a frickin' 1, right? Alright, so we'll do this first one. What's the empirical formula for compounds with these compositions? And so we've got 24.5 grams of nitrogen and 70 grams of oxygen. So we'll go boop. We'll get rid of that. Yeah, I have my I have metallic dice for DMing. I'm only in games where I'm the player currently, but if I DM, I don't roll virtual dice. I roll actual dice on the table, and like, I don't know, it's just nice for my players to hear like the sound of like actual dice hitting the table. Like, okay, does 19 hit your AC? Yeah, sure it does. You're a wizard. I know you can't block that. Even with your frickin' shield spell, you bastard. I'm only saying that because I play a wizard also, and I use the shield spell a lot. So 24.5 grams of nitrogen and 70 grams of oxygen. All right. So we want the empirical formula of this substance that has this amount of stuff in here. Remember, the first step to doing that is you want to turn it into moles. So a mole of nitrogen is 14.01 grams. So how many moles would that be? 14.01. I typed in the wrong thing. Hold on. 14.01. Because that might screw up a digit. We want to make sure that we get that right. 1.75, right? Yeah. I don't know why I wrote carbon. Don't know what I was thinking there. Nitrogen. There we go. We'll do the same thing with oxygen here. 1 gram of oxygen is 16, or I'm sorry, 1 mole of oxygen is 16 grams. Make sure that you don't do O2 or N2 here. You're just looking at the element nitrogen and the element oxygen. Otherwise, if you did O2, you get an answer that's half as big as it should be, because you'd be dividing by 32. So, 70 over 16. And so we'll make a formula out of that, and we'll just put it down here. Not a very good formula, though. So what we're going to do is we're going to divide by the smallest number. And 1.75 divided by 1.75 is 1. But 4.38 divided by 1.75 is 2.5. Real close to 2.5 even. 2.502. So we can't have fractions. 2.5 is the same as me writing this, right? So if I multiply by 2, I would clear the fractions. So we're going to do that. And that's what you get. So there's the empirical formula. Empirical formula. There we go. Now you're going to do the same process for B, C, and D. And we can come back and do another one of those later if we don't have any other questions. I just want to see. I want to try and do as many types of questions that people might have. But the gist is the same. Turn it into moles, and then make a formula, and then divide by the smallest number. So if I do this, so that you can see all the rest of these problems. Well, I guess you can't do it that way. I can just scroll slowly. So there was A. There's B. I give you a percentage. You could turn the percentage into a 100-gram sample, and then moles, and then find the ratio. Same thing for that one. Down here, we just give you obnoxious numbers and units, because, again, they're at the problem. So here I have a mass. Oops. I have a mass, a number of moles, and then a number of atoms of hydrogen. Turn everything into moles, right? So this grams of carbon, you can turn into moles. This is already moles. You don't have to do anything with it. This is a number of atoms of oxygen. Turn into moles. Divide by Avogadro's number, right? Same thing, and you'll get the correct answers. All right, and then Unit 12, Question 7. If I do this, will this change anything? Yeah, it will. Okay. 1, 2, 3, 4, 5, 6, 7. Okay. Oh, well, look, it's the same thing we just did. Now, this one is doing mass percentage in a way that we can do it the exact same way. Oops, hold on. I moved something around. That's what I wanted to do. I'm on the wrong screen, and then everything is moving on me on other monitors. So we got 30.9% sodium. 47, that's not 47. 0.6% chlorine. 21.5% oxygen. And so if we just do this, we say, okay, if I have 100 grams of compound, and I apply all these percentages to that, then I just end up with these as masses, right? So I could just do this. And then we'll do the same process we just did, right? Turn it into moles. I don't know what sodium is off the top of my head. 23 something, right? 22.99. And we'll calculator it up. So 30.9, oops, 22.99. All right, same thing for Cl. Except this one I do know. $47.6, 35.45. Oh, look at that. We get the same number. That's interesting, right? And then 21.5 grams of oxygen. $21.5 over 16. Lo and behold. I don't look at the answers for these, so when I see that they're all the same, I had an idea that this is what it was. That this was sodium hypochlorite or bleach. But I'm still always surprised when I see how well it works out. Oops, there we go. We'll divide by the smallest number, which is the same for all of them. And you get Na. I said you get NaClO. There you go. You get bleach, which is great for cleaning surfaces and your clothes if they are already white. Not so great if they're dyed with something, because bleach will decompose it. All right. So, again, that's the gist of how you do empirical formulas, is turn it into moles. Whatever thing I give it to you as, turn it into moles. I'm not going to make, like, pounds or cubic yards or whatever on the exam. But you'll probably get a mass. You can turn that into moles. Create the formula with your moles, and then divide by the smallest number. All right. I don't see any other questions up here, so let's take our break. We'll collect more questions. And we'll come back and talk a little bit more after that. So, see you in 10 minutes. Oh. Sorry about that, I was answering something elsewhere. I was going to let this just run until I had some questions in there, but then I looked over and saw one. So let me delete this. Nothing happened. That's not assuring. There we go. And then we want Unit 16. And question 13. Okay. You need to prepare 250 milliliters of 1.25 aqueous, molar aqueous sodium hydroxide for an experiment. Clearly list the steps, including the needed amounts in appropriate glassware that you'll need to follow to prepare the solution. All right, so I'm on the wrong page. There we go. I need this molarity, and I need this volume. And I know that m times v equals moles. So if I multiply these together, that would tell me how many moles of solid sodium hydroxide I have. Now, it doesn't actually say in the problem that sodium hydroxide is a solid, but it can't be a dilution because you're not being given a stock solution, right? So if the question doesn't have, like, you have this stock solution, then you can't do that because you would have to make up a stock solution, and those are already, by definition, prepared for you. So this must be a solid. So we'll say the molarity times the volume, which I'm just going to write like this, will give me moles of sodium hydroxide. And then I'm going to do this, moles of sodium hydroxide, grams of sodium hydroxide. So I can cancel this guy over here with that guy. That was sloppy. Hold on. There we go. We know the molar mass of sodium hydroxide is 40 grams per mole because it says that right there. And so we get our calculator out. There's our calculator. 1.25 times 0.25000 times 40. Oh. Grumble, grumble. All right, so there is our mass of sodium hydroxide. How do you make a solution out of anything? Step 1, add your solute. To the appropriate flask, which in this case would be 250 milliliter flask. We're going to add the H2O to the mark. We're going to mix for about... Wow, that was an X. Yeah, very good. Very good, Photoshop. That was definitely the letter I wanted to write, was that. Ugh. Ugh. I hate it. I hate it so much. I don't know what that was. That was my fault. There we go. And then, of course, enjoy. So there you go. Those are the 4 steps that I follow. I don't know if Sabina includes enjoy on hers. Let's see here. She has like 5 steps. Oh, look at that. Weigh 12.5 grams. Transfer to a beaker. Rinse with water. Add a little bit less water. Transfer the solution. This is too many steps. This is far more specific than you need to be, I think. All of this part right here. That's not quite... That didn't quite work, but... All of this part right here. I am making an assumption. Oops, you can't see what I've highlighted. In fact, what I should just do is just do this. That's not how we do that. So, I believe that you guys have the answer key online, is my understanding. But most of these steps you can summarize by just with the assumption that you are going to properly rinse all of your liquid out. Obviously, that's a lot harder to do because we've never actually done this in the lab. Hopefully in the fall quarter we will. I'm more of a stickler for it in the lab because I want to make sure that you are doing the lab technique properly. If you are waiting for me to teach 162, you might be waiting a while, but I believe that I might be signed up for spring 2023. There was discussion that I would be doing that. It is a night class, so it would be 5 to 7, and then a lab, I think, from 7 to 9. I prefer late classes myself when I'm in person. I do all the night classes. Like, nobody else really wants them. There have been other faculty who like teaching night classes on occasion, but they finally changed up the schedule such that I guess everybody was happy, and then they still had 2 night classes, and they're like, okay, we'll have... Wes, do you want both of them? And I was like, hell yeah, I do. That's awesome. So I'm super happy to do that. The problem is that you might be in a class with me from 5 until 9 on, like, Monday. Which, I don't know, there are worse things to do. You could be in a class with, I don't know, anyone in biology. That I'm just being silly there. I don't know very many people in the biology lab. I just think that the biology experiments are probably, not as cool? I don't know. I guess cool is just kind of in your own, like, definition. We do some pretty interesting experiments, I think, in chemistry. I should have said physics. Physics experiments are really stupid. Sorry, Christine, your experiments are dumb. Drop a ball 50 times and measure how long it takes. Like, I get that it's important, but it's not exciting. All right. That's that question. I'm going to make this smaller again in case we need it. But if nobody has any other questions, let me know. Or if anybody has other questions. I'm just going to mute myself. I'm going to put the music back on for a few minutes, and we'll see if we can get anything. So, BRB. I'm going to open up last call for questions. Oh, I didn't realize I didn't mute the thing here. I guess we'll just turn this down here. Hold on. Alright. So, it doesn't look like there's any more questions here. Chris, if you have more, like, questions about, like, classes and stuff, I can answer those in Discord if you want me to. But we're gonna turn this down. I want to thank everyone for coming out to the review session. And for being a part of this class. I know that online classes are difficult, and that really just everything right now is difficult, it feels like. But I hope you got something out of the class, and I hope you enjoyed it for what it's worth. Lab worksheet number 5 is due tonight. The assignment closes tomorrow. Most people will have their final exam tomorrow unless you have specifically requested a new day. Get those requests into me by tonight so that I can do those. Otherwise, your exam is going to be either Wednesday or the day you requested. Thanks again. That's all I got. I'll see you... I don't know. I'll see you whenever, I guess. But if you're taking 161 next quarter, I will see you then. So take care.